Hi, everyone. Thanks for bearing with us. We have Phoebe Liang back presenting automating pet insurance claim process with machine learning. We are doing a second attempt at the presentation, and it is broadcasting over my cell phone, so I hope the audio is agreeable this time. Thanks again for joining us, and I'll hand off to Phoebe.
Thank you, Kelly. Hi, everyone. Can you all hear me?
Yes.
Okay, great. I will speak as loud as possible. And thank you for Kelly for helping. So, and sorry about the inconvenience earlier. Okay, without further delay, let's begin the presentation. Hi, my name is Phoebe Liang, and I'm a senior data scientist at Trupanion, a pet insurance company. In this talk, I will describe the journey of how we overcome the different challenges and use machine learning to automate the adjudication of veterinary claims. And we will focus on how we design a modeling framework to solve real business problems and how data science transformed the company on the organization level. However, because of business reasons, I will not be able to share the implementation details, and thanks for understanding. Next, let's go into the agenda for today. First, we will introduce our company, the team, and the motivation behind why we want to automate claims using machine learning. Next, we will talk about how we get data to train our models. Then we will go into how we design a framework and build predictive models to predict outcome of the claim. Lastly, we will discuss how we deploy models into production and what the impact it made to the business. At the end, we will leave 5 minutes for Q&A. Next, let's talk what is Trupanion. So Trupanion is a pet insurance company based in Seattle. We provide medical insurance for cats and dogs, and we cover all new illnesses and injuries that are not pre-existing prior to enrollment. And we have been in the industry for more than 20 years now. And at the end of last year, we have a total of over 1 million total enrolled pets. So who we are. We are a small team of 5 data scientists. The pet photos on the right are pets of our data scientists. Our team's core responsibility is to automate the adjudication of claims by using machine learning. And we started doing that about 4 years ago. So now you know more about our company. Let me explain how the claim process works before we started using machine learning to automate claims. First, the pet owners will bring their pets to visit the clinic, and they pay the bill at the clinic and get an itemized invoice. Next, pet owners complete a claim form and attach the itemized invoice and send to Trupanion via email, mail, or their online account. Once the claim is submitted, claim adjuster at Trupanion will review the claim and collect any medical records needed. Then the claim adjuster will complete the assessment and notify pet owners outcomes of the claim. If the claim is covered, a direct deposit or a check will be issued. After you get an understanding of the claim process, let's talk about the motivation behind why we want to automate claims. The traditional way to submit an insurance claim is to fill out a claim form and send an invoice through mail, email, or fax, and policyholders can submit online if they have online accounts with us as well. After the claim is sent to Trupanion, claim adjusters will go through all the claim information, including the pet's medical records, and the past claim history to determine whether a claim is eligible. Even a claim is a really simple claim, it will need a human involved to process. For pet owners, they can wait days or weeks to get reimbursed for a claim. It's a poor experience for both the pet owners and the claim adjusters. If we want to automate this process, what will be the first step? The first step will be to get clean and structured data. On the right is a sample invoice. As you can see, the data is completely unstructured. It's just an image that you cannot do anything rather than a parsed set of key value pairs. Additionally, invoices can come from various image formats and qualities, and the words can be blurry or missing. To solve this problem, we build our own software for veterinary hospitals to submit claims electronically to get data, and we help them to install and integrate our software with their systems. There are two main benefits of doing this. First, the data format is standardized. We don't need to worry about cleaning the format of the invoice date, for example, and we can get rid of a lot of data cleaning efforts. Secondly, we can store all data in our data warehouse. That makes it easy to query the data and use it to train machine learning models. Next, what data is available to us? Besides invoice data, we also have data on the pet level, such as the claim history or the medical records. And we also have some owner information. For example, if they have multiple pets with our policy. And we also have some information about the clinic, for example, what hospital type they are. These are the data that are available to us. So now we have the data. Why we want to use machine learning to automate a claim? I think it's important for us to go through how human adjusters assess a claim to first understand their decision-making process. On any given invoice, usually there are multiple items on the invoice, which we call line items. For each line item on the invoice, we will determine, for example, what is the medical conditions. Sometimes a claim can have multiple conditions. We also check if the item is a direct policy exclusion, which means something that we never cover on our policy, such as preventative vaccines or wellness exams. And then whether this pet being claimed is the same pet on the policy. And after the condition is determined, there are also a set of decisions we need to make dependent on what the conditions are. Since there are a lot of interpretation and expertise that goes into assessing a claim, we need to mimic this human decision making. Our goal is to design a framework to stimulate the human adjuster thinking process. Currently, we develop a two-stage framework. In the first stage, we break down the human decision-making process and created a series of independent models that run in parallel. Each model is designed to analyze a specific item or issue. In the second stage, there is a final model which we call the aggregator. It collects all stage 1 model outputs and whether to pay a claim and what deductible to apply. So why we need machine learning to automate the claim process? Let me use two simple examples to show how machine learning can be really useful. The first example will be identifying exam fee, which is a type of direct policy exclusion that our policy will never cover. Oftentimes, the invoice item will contain the word exam, but a lot of times it doesn't. The invoice item can be technician appointment, or emergency doctor visit. The language varies from clinic to clinic and also varies from country to country. By using natural language processing and supervised learning, it can learn and recognize exam fee properly, giving enough past claim assessment data to train a classification model. In another example, we can use machine learning to check whether the pet being claimed on the invoice is the same pet on the policy. There are times pet owners use a nickname on the invoice, or they submit the wrong invoice under a different pet if they have multiple pets. We can generate features from the text data, such as computing similarity between the name on the invoice and the name on the policy, and leverage past claim assessments to see whether we paid for the pet in the past. When designing the aggregator, there are multiple things that we need to be considered in this approach. First, we need to resolve conflict between the stage 1 models, because it is possible a model that predicts denial when another model predicts pay. Also, the prediction may not be 100% accurate. So we design a solution that lets the aggregator to generate a confidence score. If the confidence level is too low, the accuracy is likely low as well. The aggregator needs to learn when to defer a judgment to human claim adjusters. When confidence is low, we route it away to human, usually on claims that need further clarifications. And due to business reasons, we will not go into the details of the implementation. And after we trained our machine learning models and tested, how do we deploy it to production so it will process the claim in real time? Because we are a small team and have really limited resources and time, we decide to focus on modeling. We outsource the model deployment to a third-party vendor that let us define our own model APIs. Whenever we need to deploy a new model or make any changes, all we have to do is to publish a new version of the model API on the predefined interface. Once it is in production, how do we continue improve the model and know if there are any errors we need to adjust? We work closely with our claims department, including setting up daily reports to review claims with high dollar impacts. And we create a form that is easy for claim adjusters or anyone inside the company to report errors to us. By using machine learning to automate claims, we have made a big impact on the business. First, it has much better customer experience. We are now able to pay directly in seconds rather than weeks. We also help the company to scale operations and invest resources in other areas as we continue to grow. That also give us competitive advantage over other companies. And this concludes the end of the presentation. And thank you, and I will open up for Q&A. And I also leave my LinkedIn URL on the question slide in case there's other question I'm not able to answer in the Q&A. Feel free to connect with me.
Thank you, Phoebe. For all the attendees, just a reminder to post questions in the Q&A, and I will be here to read any questions to Phoebe so that she can answer. We'll give you a minute to submit any questions you have. Well, I'm not seeing any questions, so anyone should feel free to reach out to Phoebe via LinkedIn. And thank you all for joining us and for tolerating our technical difficulties. I hope you've had a great conference and have a great day.